All right, we're going to take a look at sector area of a circle today. We have already discussed one of these formulas, the one we see here. We have talked about the arc length. This is our arc length formula. We use that a lot the last 2 days. If you want to add to your notes, this is going to be the new addition to our notes, and that is our formula for sector areas of a circle. You could even call this partitions of a circle. We're just talking about parts of a circle. And this is our formula right here. I'll keep the other one in the picture as well, just so that you can see it. So we're looking for the area of a circle here. One thing I want to highlight to you, and just like yesterday, remember this was the circumference formula because that's what we were doing, is we were finding a proportion of the circumference. Well, today we're talking about area. So we use the area formula, and we are going to multiply it times whatever proportion we have of the circle. And the way we do that is we take the degree measurement that we are given and we divide by 360. Again, I put the pi behind the r. The reason why I do that is if I'm asked to answer this question in terms of pi, I'm ready to go. It's already set up. So this is the first example on your Delta Math, and what we're going to do is we're just going to kind of talk about how we find the sector that we're talking about. We know that a triangle, or excuse me, a circle is made up of 360 degrees. Well, we don't have the entire picture here. What we are told is we have 7/10 of a circle. Well, if we have 7/10 of a circle, then we have 7/10 of the 360 degrees. So the way we find the degree measurement is we multiply these together. 7 times 360 would be 2520. And then this is over 1, so it's over 10. So the degree measurement that we have for 7/10 of a circle is 252 degrees. We have 252 of the 360 degrees. So this one is exactly the same, but completely reversed. On the last one, we took the partition of the circle that we're dealing with, and we found the degree measurement. On this one, we're given a degree measurement, and we're asked to find what part of the circle we have, what proportion. So we have a 225 degree angle measurement. That is 225 of the 360 degrees. So all we need to do is divide 225 divided by 360. This reduces actually to a fraction 5/8. So 225 degrees is 5/8 of a full circle, which means when we start talking about our area, it's going to be 5/8 of the total area. Kind of started with kind of a backwards that I really intended, but that's okay. We can still take a look at these and see. So in this example, we're told we have 130 degrees and the shaded region has an area of 13 over 9 pi. Well, let's go back and think about what our formula was. Our formula is equal to the area, the sector of the area of the sector is equal to the angle measurement divided by 360 times the radius squared times pi. So there's 3 parts to this that we need to have that are involved. The area, the angle measurement, and the radius. The other parts are unchanging. So we need to identify what we have. Well, we have the angle measurement of 130 degrees. And in this case, we actually don't have the radius. We have the total area of 13 divided by 9 pi. Now, before you get too worried about this, a lot of times pi is going to take care of itself, just like it is on this one. So this is 13 over 9 pi is our area. And we know that we have 130 of the 360 degrees. We do not know what our radius is, and we know whatever we do, we're going to multiply times pi. Now, just like yesterday, we don't want to let this pi value just follow us along. So we're going to divide both sides by pi, which is essentially canceling the pi's out since we have them on both sides. Now, the next step I'm going to do, which is not completely necessary, we can actually reduce 130 to 13 over 36, r squared, and then we have 13 over 9. Now, the next thing we need to do is to get r by itself. Remember, we could divide by 13 over 6, but we really want to get in the habit, I want you to get in the habit of, instead of dividing by 13 over 36, multiply times the reciprocal value. So I multiply the left side times the reciprocal value and the right side by the reciprocal value. Maximize this a little bit. So this is what it looks like. Well, on the right side, the 36 cancels the 36, the 13 cancels the 13, just like we were planning on it doing. And on the left side, when we multiply 13 over 9 times 36 over 3, we end up with 468 divided by 117. Now, before we go square rooting, you want to make sure that this fraction doesn't reduce. Anytime you can work with smaller numbers, you really want to do that. And in this case, you really want to do that because this actually divides down to 4. So we have radius squared equals 4. The way we get rid of a square is with a square root. And the square root of 4 is 2. So there's our radius. We have a radius of 2. This is an example more like what we're going to see because we usually have the radius and we usually have the degree measurement. It's usually the area that's kind of hard to find. So in this one, we want to highlight what we have. We have a measure of JK, the radius is 2, and then it tells us that the measure K to J to L is 144 degrees. We can go back to our formula. This is the theta divided by 360. And then we're going to multiply that times our area formula. It's just a portion of the area formula is what we have here. Again, we highlight what we have. Three parts are the area, the angle measurement, and the radius. You got to have 2 of these 3 in order to answer. So we know what the angle measurement is. It's 144 degrees. That's 144 of the 360 degrees. If you wanted to simplify that right now, you could. It's completely up to you. We also know that we have a radius of 2. So this is 2 to the second power times pi. Now here's what we want to make sure we look at. It does say leave your answer as a fraction times pi. So really all we need to do at this point is to put all of our information that is in front of the pi into our calculator, calculate that, and then we can see what the pi is. So what we don't know actually, is this actually reduces to 2/5. 144 over 360 is 2/5, and 2 squared is 4. So our area is this, and 4 times 2 is 8 over 5 pi. If you would have put all the stuff that I highlighted in yellow there into your calculator, you would have gotten 8/5. Don't forget on your calculator, if you want to convert something back into a fraction, you go math, enter twice. Math, enter, enter. And that will change whatever fraction you have into a decimal. Again, if you are putting in pi into your calculator, it's going to be impossible to turn it into a fraction. Pi is not a variable, but when we're asked to answer in terms of pi, we want to treat it like a variable. I really like this question. This kind of brings in a couple of things. Both the area and the circumference of a circle. We'll need to do both. But remember this, anytime you're dealing with a circle, the most important thing is the radius. We've got to have the radius. And remember, if we have the diameter, we have the radius because the diameter is twice what the radius is. So you have the information if you have that. So let's read. It says circle S. ST has a measure of 2. The length of TU is 11/9 pi. Find the area of the shaded region of the figure. Well, we have the radius here, so that's really nice. And we have an arc length. So what we actually have to do here is go back to our arc length formula, which was S equals the angle measurement, that's theta. If you want to put X there, you can, by the way, because theta is just like X is an unknown number, theta is an unknown angle. So we know this is 2 times radius times pi. Again, we have 3 parts, just like on the last one. We have the arc length, we have the angle measurement, and we have the radius. Well, we have the radius, and we have the arc length. So we're just going to input the information that we have. The arc length is 11/9 pi. Zoom this in a little bit here. The arc length is, again, 11/9 pi. We do not know what the angle measurement is, the central angle. So that would be left as theta. And again, if you want to change that to an X, you are more than welcome to. And then we are going to go 2 times the radius, which is 2, and then times pi. So we have that same situation we had just a moment ago. We have pi on both sides, so we could go through and divide by pi, just like you see me doing there. Or what we can do is just cancel those out. Cancel those out from either side. So pi on either side goes away. So I'm going to do some math on the next step as well. 11/9 is going to be fine. The unknown angle, theta, over 360. And then 2 times 2 is 4. So we've taken care of that math. So I need to get rid of 4. The way I do that is I divide by 4, or I multiply times its reciprocal. The reciprocal of 4 is 1/4. I like doing that on this particular question because we have a fraction on the other side. So here's what we've got. Just like you see there. And we actually could set a proportion right here, or we can find our angle. The way we would find our angle is we would multiply both sides times 360. Well, if we're doing times 360, well, that cancels out the 36, and that would be 10. So 10 times 11, we have a 110-degree angle. All right, so we've done all that to figure out our angle is 110 degrees. Now we actually could have kept our proportion, solved this equation with the proportion, this section here. May do that on the next example and leave it as a proportion. It might be a little easier for us. But now we have all the information we need in order to find the area of this same shaded region. So as we look at this, we see this region here is 110 degrees, but the shaded region is the region on the other side. Well, there's 360 degrees in a circle. 110 of them are in there. That means 250 are left in the blue shaded region, which is the region we're looking for here. So this is the formula. This is what we will take to our area formula. Draw a line here. Remember, area equals our angle. Well, our angle is 250 of the 360 degrees. Times our radius, which is 2 squared times pi. At this point, we could put all of this information into our calculator, leave the pi out until the end, put all of that in, hit enter. It's going to give me an answer, and that would be the correct answer, actually. But let's go ahead and solve this out by hand just to do it. Well, 25 and 250 and 360 both have zeros, so we could actually drop the zeros in a reducing fashion. So, and then 2 squared is 4. So we end up here. And we go 4 times 25, which is 100 over 36. And what we did there, in case you're not noticing this is 4 times 25 because that's 4 over 1. That equaled the 100. Now we have a pi amount. So our area equals 100 over 36 pi. Well, both of these numbers have a factor of 4. Probably should have just canceled the 4, but that's okay. We did what we did. When we break a 100 down, it reduces to 25 over 9. And then we have pi. So the area of our region here is going to be 25 ninths pi. That was a lot going on, I understand. We're going to do the next one. We'll try to leave it in a proportion, and we'll see which one you guys like the best. So this one is the other way around. We are given the area of a shaded region, say shaded sector, and we're asked to find the arc length. So we are going to start with our area formula. Area equals, remember it's the angle measurement over 360. In this case, we have the area, so it's going to be radius squared times pi. Well, let's see the parts that we have. We have the angle measurement of 40, so we will replace the angle measurement with a 40. And in this case, we have the area. Well, that's 4/9 pi. So we need the radius. Probably the trickiest part when we're looking for the radius, because we will be taking a square root at some point. I'm going to maximize this a little bit so we can see what's going on here. Well, I'm going to first go ahead and reduce 40 over 36. If you put this in your calculator and you do the math, enter, it's going to reduce it to 1/9. And I'm going to do another thing before we move down, and that is to get rid of those pi's. Both sides have a pi. They are completely unnecessary, so we're just going to get those. They offset one another, so we'll get rid of them so we're not just toting around pi's all the place. So here we are. We have 4/9 equals 1/9 r squared. Well, again, I don't want to divide a fraction by a fraction. It's much easier to multiply times its reciprocal, and the reciprocal of 1/9 is 9, but we're going to leave it in 9 over 1. Well, 9 over 1, these are going to cancel. 4 times 1 is 4, so we have 4 is equal to, and on the left side everything right side everything canceled. equals radius squared. Radius squared equals 4, excuse me. So we are going to square root both sides, and our radius equals 2. There we go. So here's the thing that's nice. We were looking to find the arc length. Well, we can use the proportion. Remember, we solved for this proportion right here. We discovered that 40 degrees of 360 is 1/9 of a circle. So as we look at this, we're looking for the arc that's marked, which is this large arc. They gave us the area of the small piece of pie, and we found that it's 1/9 of the entire thing. Well, that means if it is 1/9, then the other side has to be the other 8/9. 1 minus 1/9 would equal 8/9. So if this little arc right here from U to V is 1/9, we have 8/9 left. So we are going to take 8/9 back to our equation. We have 8/9 of the circle. And the formula is 2 times the radius times pi. Well, the radius has not changed. We just solved the radius to be 2. So we are going to plug in the radius of 2, which looks like this. We were asked to answer in terms of pi. So this ends up being 8/9 times 4 times pi. Again, pi is not a variable, but we're going to treat it like one because we were asked to answer in terms of pi. Well, this is 8 times 4, which is 32. 9 times 1 is 9. So our arc length is going to be 32/9 pi. And if, just like yesterday, if the pi button doesn't show up, remember you can just type in, I think you can just type in pi, but if you hit the coding, it would be pi, and it will give you the pi symbol. All right, I hope this was helpful to you. You have the rest of your assignment working through these arc lengths. It may be wise to start with the last part, the last section, while you have me in class, and I can help you through those. Good luck.